Okay, so now you try a problem. So this is very similar to the last question. Pause the video here for a second, work through this, and then come back and check yourself. Okay, so let's take a look. So I entered the data into a list in the calculator, did one variable stats, and got our point estimate, which is x bar 6.48. The requirements for the test are that we have a random sample randomly selected here, and that is satisfied. Normal population or n greater than 30. Well, our sample size is only 10. However, here we know the population is approximately normal, so that one is satisfied. The S value I got from one variable stats, sample standard deviation 0.718. My t value, inverse t of 0.975, 9, 2.262. Plug those into our confidence interval formula. So here's our x bar plus or minus t value, s over square root of n. I got 5.97 to 6.99. So is it possible that students get the recommended 7 hours of sleep? Not likely, because we're 99% confident. 95% confident. I was right the first time. 95% confident that the true population mean hours of sleep is between 5.97 and 6.99. So that means 99% of samples should contain the true population mean. And this is one of those samples, and it does not contain 7. So it's only 5 samples out of 100 would contain 7, is what we're seeing here. Well, only 5 samples out of 100 would not contain the true population mean. So it's not likely that 7's the true population mean. So 7 is not an element of the interval 5.97 to 6.99. So that's when you can draw a conclusion, is when the number is not in the confidence interval. And you can confirm this on the calculator doing the t interval. And let me just mention one thing here. So if we go to stat, tests, and then down to t interval, number 8, we have data. So we enter the actual data. If you don't have the actual data, but you have the summary stats, then press stat and enter, and it'll ask you for x bar and s. Now it's actually put them in here for us from the data, and our sample size of 10, and then our confidence level was 0.95. And there we're getting that same interval of 5.97 to 6.99. So that's if you have the summary statistics and you don't have the data. We actually had the data, so you can go right from the data. So you can do stat, tests, 8, and then use data. Highlight data, everything is the same, calculate, and there's that same interval. So the calculator will do it from actual data or just from the mean and standard deviation and sample size.